Okay, in section 3.1, we will talk about pure substances and also talk about its states. Okay, well, for pure substances, you should have learned this in your high school science class, but I just would like to talk more about it because we need this definition to help us talk about the things later. Okay, well, what is pure substances? It is defined as a substance that has a fixed chemical composition. Okay, for example, some common substances like water, nitrogen, and also carbon dioxide are some examples of pure substances. Okay, well, this kind of pure substances will include some single elements here. Okay, for example, for nitrogen, we will have only one element N. Okay, but we will also consider some homogeneous mixture of various elements and compounds to be also pure substances. Okay, for example, gaseous air. For gaseous air, we will also consider this as pure substance because although air consists of a lot of different kinds of gases, for example, oxygen, nitrogen, carbon dioxide, and also other noble gases. But because they mix well and you can only see one phase, so we will also consider air to be a kind of pure substance. Okay. Another kind is that we have mixture of more than one phase of a pure substance. Okay, but we'll also consider this to be a pure substance. But note that they need to have the same chemical composition. For example, water, ice, and steam. Suppose at a particular pressure and temperature, we can have all of these three phases exist, having liquid water, solid ice, as well as water vapor to coexist. Okay, they have the same chemical composition, that is H2O. So we will also consider this as a kind of pure substance. Okay. However, if the mixture consists of two or more substances with different chemical composition, then it will not be a kind of pure substance. For example, oil and water. From daily experience, you will know that oil would always float on water due to its lower density. And you can see that oil and water cannot mix well, and you can see with your naked eye that they separate into two regions. So they have two phases here. And also, another example is liquid air. Okay? For mixture of liquid and gaseous air, it would not be a kind of pure substances. It is because air has a mixture of gases and they have different melting points. That means at a certain temperature, only some of the gases condense. And of course, this kind of liquid air would not have a fixed chemical composition. Okay? So that will be some knowledge of pure substances. Okay? Next, we will talk about the phase of a pure substances. Okay? As we have heard that typically, a pure substance has three phases: a solid state, liquid state, and gas state. Okay? We will use the molecular model to describe this state. For example, a solid state, they will constantly vibrate about their fixed position and they are closely packed. For liquid state, we have the groups of molecules which move about each other. Okay? They have more freedom of movement, but they are still confined. But for gas state, the molecules move randomly. Suppose you have a container, then this gas will fill up the whole container. Okay? And the volume depends on the size of the container. And for the intermolecular force, because the molecules in solid state are packed most closely than all the other states, so it will have a larger intermolecular force. And liquid will be at the middle, and gas has the least intermolecular force. Okay? We will also have other phases. If you have heard what plasma and liquid crystal is, okay? There are other phases, but it is not a focus of this course. We will just focus on solid, liquid, and gas. Okay? Okay. Next, we will go to a so-called optional section. It's talk about the phase characterization. Okay? Well, this is optional. If you don't understand what I'm talking about in this section, never mind. Okay? As I've said that the intermolecular force in solid is strongest. Okay? And liquid will have a smaller intermolecular force. And for gas, it will have the smallest intermolecular force. Okay? The reason is that, as I've mentioned, solid have the most packed arrangement. So the average distance between the molecules would be the shortest. So they will have the strongest intermolecular force. Okay. And here we will also have a list to talk about more about the phases. Okay. I've mentioned the intermolecular force. And what about this? Let me explain what is mean free path. Mean free path just means the average distance in which the molecule would collide with another molecule. Okay. For solid, you will see that R0 is the atomic radius. That is the average distance between the atoms or molecules inside a substance. Okay. For the mean free path, you will see that for solid is much smaller than 1 because solid has a very closely packed arrangement. So if a molecule moves, it will just very easily collide with another molecule. So the mean free path is quite small. For liquid, its magnitude is quite close to 1. So this big O notation just means the magnitude of the things inside the bracket. So it has a magnitude close to 1. That means about the atomic radius. For gas, it will have a much greater mean free path. Okay, because the gas has a very loosely packed arrangement and the average distance among the molecules is quite small. So we'll have mean free path much greater than the atomic radius. Okay. And I have talked about the molecular arrangement already. And for solid, due to the very small distance among the molecules, we need to use techniques from quantum mechanics to solve it. For gas, we will use a classical approach. That is, we use the statistical approach to characterize the phase. For liquid, it will be between solid and gas, and it's quite difficult to characterize liquid phase, okay, because it's between solid and gas. And here is just a graph talking about how we can determine the so-called interatomic distance or the bond length. Okay, if we have the smallest potential energy, okay, that means the two molecules are in the stable equilibrium. Okay, and at that time, the net force acting on it will be 0. Okay, but why we will have a repulsive and attractive force? Because if the two molecules or the two atoms are very, very close or extremely close to each other, then they would repel due to their positive charge nucleus. However, if they are not quite close enough, then the intermolecular force would try to attract them towards each other. So we'll have two forces. Okay? And what we call the bond length is the distance or the equilibrium distance that they can have, such that the magnitude of the repulsive force will be equal to the magnitude of the attractive force. Okay, so there will be more description about the phases. Okay, again, if you cannot understand what I'm talking about, never mind. You just need to bear in mind one thing: is we have three phases. We have solid phase, liquid phase, and the gas phase, and you need to know the molecular model. Okay, and that's fine. Okay, so let's go to the next section.